If you have a good understanding of acidity and analyzing conjugate base stability, you already know everything you need to know about bases and basicity. It's really just the opposite trend. So just a couple things to keep in mind. The first is neutral versus negatively charged bases. In general, if a base has a negative charge, it's going to be more basic than a neutral base. You want to stick with this comparison for similar atoms, meaning you can compare NH3, the neutral base, versus NH2 minus, the negatively charged base. This one is going to be more basic. What you're looking for in a base is something that is unstable, and this is the least stable. Why? That base needs to go after and grab an acid or a proton from an acid. Of these two, which is going to be faster? The neutral one or the charged one? The charged one is more reactive, and that's going to be faster. So some things that really go hand in hand here. The NH2 minus, it's less stable. That means it's more reactive. That means it's more basic, and it reacts faster with an acid. So what we can say is a less stable negative charge is a stronger base. You can analyze this using the conjugate base stability rules we learned with the acids. So let's apply this to a few examples. So if we just look at these, I'm going to start with the compound on the bottom right. Here the negative charge is stabilized through resonance. So this is going to be the least basic. Then comparing that to the non-resonance stabilized S minus, this one will be a little bit more basic. But between these, we know that oxygen and sulfur on the periodic table, sulfur is larger. So this anion is more stable due to size compared to oxygen, which is less stable. So actually, let's just give these a ranking. 4, 3, 2, and then comparing the O minus and N minus, those are in the same row on the periodic table, so we use electronegativity to analyze. O minus is on an oxygen, which is more electronegative than the nitrogen, so the N minus is even less stable. So for basicity, that would be number 1. So it's really just the opposite analysis that you did for acidity.